Hello everyone and welcome to an introduction of 0.95 confidence intervals. My confidence interval series will be spaced over different videos. This one's the introduction. Unlike other video series, it won't be in parts. Each video will focus on a specific technique. Today is just doing two basic questions and understanding what confidence intervals are. So first off, confidence intervals. I've wrote a few notes up on the board. Let's go through them and think about what they mean. It's good if you have some doodling paper in front of you, just to write some notes, draw some things, and consider what I'm saying. So we've been learning stats now for quite a while, done quite a few videos, hopefully you've watched a few of them, and you know that we've been able to calculate things like population mean, standard deviation, z-scores, that sort of stuff. But now, what the confidence interval is a very powerful tool. It's probably one of the most powerful statistics tools you'll probably come across. It's about finding a range where the population mean lies. So we've gone out, we've taken a sample, I don't know, maybe we've gone and taken the sample life that pens actually have, and what we've done is from that, based on our sample, if we know the standard deviation of the population and we know the sample mean, then we can actually calculate a range of values where the population mean will lie. And if we look at it at the 0.95 actual confidence interval level, then we can be 95% confident that the population mean will lie in the range we specify. So don't get this confused. Don't think, oh, this means we're 95% confident that the population mean is a certain value. No, this is not the case. It's not the case that we're 95% confident that a sample mean is the actual population mean. No, it's us being 95% confident that a range we have found, based on some central limit theorem and based on some normal distribution techniques, is actually an appropriate range for the population mean 19 times out of 20, or 95% of the time. Now in future videos I'll go through a few other things. I'll go through things like what a greater sample size does, and what happens if we want to look at a confidence interval that's greater or less than 95%. What if we want to be 99% sure that the population mean lies within a certain set of values? And again, that's something I'll go over in a later video, but for today I'm going to introduce you to the confidence interval formula and we're going to calculate a few things. So take down a few notes about what's on the board. Again, to put it simply, finding population mean range and being confident about it. That's what the confidence interval is all about. But again, it's not how confident you are that a value is a value. It's just saying that 95% of the time it's going to be within this area. So let's get into it. I'm going to introduce you to this formula and hopefully you've got these notes down. So, if you haven't, well, you can always rewind. That's a good thing about videos. This is the confidence interval formula. For 95% confidence, or 0.95 confidence. Okay, so as you can see there, we've got the sample mean, we've got a value, we've got the standard error, or sample error, or sampling error. We have the population mean, we have the sample mean again, I've got a little bar there, and we have the same thing on the other side, but whoa, there's a plus there, and there's a take there. So what does this mean? Well, this is our sample mean, this is a value we calculated. And that probably looks terrible, but nonetheless, this value here, if we think about it, we actually draw a bell curve. This is what we're actually doing. If we had a z-score of negative 1.96 and 1.96, then 95% of the values would fall there. So essentially that's the number of standard deviations, and you may remember that this is to some degree the sample standard deviations. So essentially what we're doing is we're saying, okay, well this is a sample mean, and we're subtracting 1.96 number of standard deviations to the left of the mean that makes up the certain proportion we want, which again, when you add it to the right side, we get 95% overall. And we're multiplying it by some standard deviation. Okay, so now how do we apply this formula? Well, that's very simple, and you can do it on your calculator even. but I'm going to show you how you can do it by hand. Well, mostly by hand, but we'll actually do the calculations on a calculator. So we'll interpret a question, and as you can see here, I've really quickly gone over what some of these values are. But sample mean, I've vaguely explained what this is, but will become more apparent in time. For the moment, again, just think about it, and think about that 1.96 value and what it actually means. Because you know, based on the empirical rule, that two standard deviations either side of the mean are actually going to make up 95.45%. Well, of course, it makes sense. It will be just less that for 95%. But just have a think about it, and think about what this value here is, the sampling error, or the sample error, or the sample standard deviation. It's referred to as many different things in statistics. But it'll become more apparent, and especially in the later video where I'll probably go over 0.99 confidence intervals and 0.96 and a few other different values, because that value changes depending on how sure you want to be that the population mean is there. Again, you can't have a 100% confidence interval. Why? Because although it may be very unlikely, the actual distribution goes to positive and negative infinity. So you could say that your population mean, if you want to be 100% confident, is somewhere between negative infinity and somewhere between positive infinity to be 100% confident. Because you could just have a really, really, really bad sample, and the population mean is nothing like it. But again, we generally look at it at a 95% level, because most of the time we're correct. Most of the time we know where it sort of lies, within a range. But again, this will become more apparent. For the moment, just note it, have a think about it. What is a confidence interval? What does it mean? You will really get an appreciation of it if you use it and you know what it does. So I'll go over this in future videos and I'll make it more clear, but for the moment just have a little think about some of the basic concepts I talked about. 95% actually making up that 1.96 there and that 1.96 there, this value here, and sample mean, taking a sample and from that being able to work out a range where the population mean lies. Now I've probably babbled on for way too much, so let's get into doing some simple math. Okay, so I have a little problem here, a little question, and let's work through it together. So it says here that a can of soda, or in fact it says a bottle of soda, sorry, has actually been having quality control issues. So it's a company that produces bottles of soda, and they actually have a filling machine that fills volumes on their soda bottle line. So to determine if the machines are correctly filling the bottles, a sample of 25 bottles were taken, and their volumes were measured. So first off, we know that N is going to be 25 bottles, because they've taken that from the line in order to calculate it. The mean volume in each bottle was 995 millilitres. So that will be our X bar from those 25 samples. And we'll calculate a probable range for which the population mean lies. The standard deviation is known to be 10 millilitres. So we know standard deviation is 10 millilitres. So it asks from this, determine a 95% confidence interval for the actual mean fill volume for all the bottles on the production line. So we want to be 95% confident that we get the population mean for those bottles across the entire line, not just those 25 bottles. So again, we use the formula, and we substitute in the values accordingly. So we have X bar take 1.96, lots of sigma on root n, less than or equal to mu, less than or equal to X bar, plus 1.96 standard deviation over square root n. So in this case, when we substitute in our values, it's 995, take 1.96, lots of 10 over square root 25, less than mu, less than or equal to, I should say, X bar plus 1.96, and X bar, of course, is going to be 995 plus 1.96, lots of sigma, which is 10 on square root 25. That's quite a lot to digest. However, what I'm going to do in this video is I'm going to show you how you can use it on your calculator and how you can work it out by hand. There, I've put in the values. Hopefully you can see I've just gone boop, 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 and actually put in the values based on the question. It's just about interpreting the question. Confidence intervals are incredibly easy, and as I said before, powerful. But now from this, what we want to be able to do is not shake the tripod. But apart from that, we go to our calculator, our TI-84, and it's always good to get a fraction bar up to make sure you don't make a mistake with brackets. But you turn it on, go alpha y equals, scroll down to 2, press enter, and then you want to type in the top row. In fact, before you get the actual fraction bar up, go to the left of it, so just press the left key. You type in 995, take 1.96, then do the multiplication sign, then go onto your fraction bar and do 10 over square root of 25. So this will give us our lower bound for the actual volume. And our lower bound for the actual volume is 991.08. Less than mu, less than. And what this means is the lower bound, so our population mean, can be as low as 991.08 millilitres. So again, we're finding a range to population mean. And then again, to do the upper bound, just press the up key, get it on the actual formula, press enter, you get it back again, and just change that actual take to a plus. I'm sorry, I don't know how to do this on a Casio, but again, we get 998.92 millilitres on the upper end. And what this means is we can be 95% confident that our population mean lies there. So 95% of the time, we can be sure that the population mean will be in that region, unless this sample is very, very dodgy and not really a really good representation. Again, remember, the only way to get a 100% confidence interval is to actually go and say, okay, our lower bound is negative infinity and our upper bound is positive infinity. Because again, you know how the normal distribution works. I've explained it in a few previous videos. So, yeah. But now, if you want to do something a bit differently, you don't want to do it by hand, you don't want to deal with the algebra, that's okay, I understand. I really appreciate this formula and I love calculating it by hand, but I understand that you probably want to do it on your calculator, so that's good. So in order to do this, what you want to do is you want to go on your TI-84, you want to press the Stat button, and then you want to go across at the top until you get to Tests. So I'm not sure how this will show up on the camera, probably not too well, but I'll say it anyway, and I'll hold my camera out enthusiastically nonetheless. But what you want to do is you want to go to Stat, and then you want to scroll across to Test by pressing the right button a few times, and you want to go down to Z interval. Z interval. It's not called confidence interval, it's called Z interval. And it's number 7, so you can just press the 7 key and you'll get there as well. But now you can type in your data just the same way. So make sure the input is set to stat. So I'll put it here. The input is set to stats. Because what are we doing? Stats. Makes sense. Now, sigma needs to equal, and in this case it will be equal to 10. So don't actually go ahead and do 10 over square root 25, because it's asking for sigma, the population standard deviation, not the sample standard deviation or the sampling error, because your calculator is very smart. It's going to go, okay, that's sigma, I'm going to divide that by the n value you put in just a moment. It does it for you, so don't get fooled. When it asks a sigma, it wants a population standard deviation before you modify it. Now, x bar, we know that to be 995, our sample mean. X bar, 995. So we put that in. Then, how many bottles do we have? We have 25, so we put that in as n. Our C level is 0.95 for this particular video, and hence it gives us the same interval. It gives you a lower bound and an upper bound in between a set of brackets, and there's a comma separating in between. And then just to remind you, it has the sample mean and the sample size underneath, just in case you forgot. So that's how you do it on your calculator. Hopefully you're able to follow along with it. You probably aren't able to see that too well unless I tilt it like that, but you're able to get a Z interval there. So again, I'll just go through the process. Just to remind you, you go Stat, you go across to Tests, and then you scroll down to Z interval. This actually works pretty well. I might do this in the future for calculator instructions. Again, you want to go to Stats, and you want to plug in your values 10, 995, 25, confidence interval, and calculate. I'm actually quite impressed by that. I know it's a little bit blurry, but at least you can see it. Okay, So we've done that question. We've worked out a confidence interval. We found out where the population mean most likely lies. Now, just one more catch. Let's do a slightly more difficult problem. Let's have a look at something a bit more interesting. Let's have a look at something related to these soda bottles, but something that can help us fix the machine. Because, of course, it's always good to say, okay, we've got a range for the population mean, but we don't want a range. We want to be able to know what values will help us, not what the actual value is in reality. Because sometimes things don't work the way you want them to be. You want them to be precise, exact, and functional. So let's have a look at that example with our next question. I'm going to rub off all this beautiful maths now. And let's see what they ask for. So company has responded to what we found. It asks, what is the fewest number of soda bottles needed to be measured in order to be 95% confident that the sample mean differed from the population mean by less than 1 milliliter? Okay, so the sample mean, or should I say the number of samples actually, will affect the confidence interval width. The more samples we have, the more precise we are with our range. Because if we get a sample mean of like 1 million bottles, you know we're going to be pretty close to the population mean compared to just taking 20 bottles. So the company wants to know how many bottles do they have to survey before they can actually, before they can say that the variance from the population mean and sample mean at a 95% confidence level will actually be less than 1 milliliter. So in order to do this, it's quite simple. We just take 1.96 times by the sampling error, or sample standard deviation, and we set it equal to 1, because this will give us the lowest number of bottles needed to have a 1 milliliter accuracy with sample mean to population mean. And we know what sigma is. Sigma is equal to 10. So from this we can rearrange the equation and solve for n, because that n value tells us how many we have to sample to get a pretty good indication of what's actually happening with the population mean of the machine. So 1.96 lots of sigma on root n can actually be rearranged, to equal 1 on square root n. So all I've done is I've brought the denominator on this side, the left-hand side, up to the numerator on the right-hand side. And because it's 1 times square root n, it's just the same as having square root n. Very simple. So now let's sub in sigma. So it's 1.96 times 10, and we know that that's 19.6. So 19.6 equals square root n. And that n value will tell us how many bottles need to be sampled. So now to get rid of that square root, we square both sides. So 19.6 times 19.6, which is 19.6 squared if you want to write it in that notation, equals n. And that's when we turn to our calculator and we go 19.6 raised to the power of 2, and we get a value for the number of bottles that need to be surveyed. And in this case, number of bottles that need to be surveyed to get this level of confidence to a precision of 1 milliliter difference from the sample mean and the population mean, 384.16. But it's bottles. We can't have 0.16 of a bottle. That's crazy talk. But we can't change it to 384 either, because if we have 384, it's going to be slightly over 1. So we have to round up. We can't actually round down. I know that's confusing, but think about it. If you had less than that value there, your precision of your actual confidence of the population mean being different from the sample mean by 1 milliliter wouldn't actually be 1 milliliter. It'd probably be 1.000 something, 1.1 even, or something like that. So we have to say that the number of bottles that need to be surveyed to get this sort of level is 385 bottles of soda. And because of that, we have been able to calculate the mean number of tubs, or mean number of bottles, sorry, that need to actually be taken off the assembly line to get that precision. So hopefully you've enjoyed this video on confidence intervals. It's just a little introduction. There'll be more videos to come, It goes through the basics, explains a little bit of it. However, there are still a few things that you will learn over the process that will help you more. So watch out for my newer videos on confidence intervals coming soon. Hopefully you enjoyed this. If you have any comments, please, of course, leave them below. Subscribe if you want to. And again, hopefully this video helped you with your mathematics and statistical knowledge. See you later, and thank you very much for watching.